So last but not least, we have Tracy Teal, who is the Executive Director of Data Carpentry and the Adjunct Assistant Professor at the Beacon Center for the Study of Evolution and Action at Michigan State University. She has a PhD in Computation and Neural Systems. She received that from Caltech and a master's focusing on computational linguistics from UCLA. Her research focuses on how agricultural practices affect soil microbial communities and how those communities affect changes in the production and consumption of greenhouse gases. She has experience in various methodological approaches and has assisted, in the software development in several ways. She's going to talk about Data Carpentry's efforts to develop and provide training on the fundamental data analysis and management skills us researchers need. Thank you.
Hi, thanks for that introduction, even though I wrote it. It sounded a lot shorter when I wrote it, but I had to throw the computational linguistics part in there to try and get some credibility with this audience. It's been a while since I worked on that project, though, I must admit. So yeah, I'm going to talk today. I really love Jahan's talk and the optimism in that talk and this focus on what can we do now. And so what I'm going to talk about is opportunities in training and how I think that training is a key piece in making us moving us towards these better practices. Because a lot of times it isn't that people don't want to do them, there's definitely that element, but a lot of times people can't do them or feel they can't do them. And so offering training at least gets people started on this pathway towards having better practices, knowing the skills, and baking a lot of these things that we want people to do into the training from the start. So I'm really excited to have been invited to speak with you today. So here it is. For you, those of you on Twitter, we're at Data Carpentry. So as you all know in this room, our increasing capacity to collect data is changing research. This is the kind of the 3 V's of big data. It's increasing in volume. That's what we sort of think about most, that you have just a lot of data. But it's also increasing in the velocity, so how quickly we're getting this data. If you think about the internet, right, every millisecond, that's not the kind of data we usually deal with, but we are really increasing the rate at the data comes to us. Similarly, the variety of data. So you might have geospatial data along with survey data, along with some tabular data. So we're getting all these different types of data, even bringing them to bear on a single question. Data production is now no longer the bottleneck. This is a real picture. This is super cool. This is from the Library of Congress. So the production of data is no longer a bottleneck. I mean, when we talked about these data sets as really being what define people's careers, that's still, some of the case, but we're not typically really waiting around for data in quite the same way that we were before. And working with big data is no longer the domain of specialists. We can't rely on people who we hand the data over and they conduct these big analyses and they give it back to us. Instead, it's really being widely done by all researchers. And when I say big data here, so Duncan at the beginning said, oh, big data, and we don't consider that we have big data. But I define big data as data that is larger than you are used to working with. So if you're used to working with something that had, 200 rows in Excel and now suddenly it has 35,000, that's big data. If you're an astronomer and you're used to working with 10 gigabytes and now you have 10 terabytes, that's big data. So what it is it's just a representation of a need for a change in working style in how you work with your data. However, this is the experience of most researchers with data. You get the data back, you're so excited, and then you are very sad or very angry when you start to work with this data. And there are a lot of reasons for that. But so the question is, how do we scale data literacy along with data production? So along with producing all this amazing data, how is it that we can train people to work effectively and reproducibly with this data? So training is really this missing piece between data collection and data-driven discovery. So turning data into knowledge. And it's not just, us in this room saying, oh, researchers need to figure out how to work with data. It's researchers themselves that really want these skills and are demanding this training. So this is a survey in bioinformatics in Australia. And so in this survey, the respondents say that their most challenging thing in bioinformatics is a lack of expertise. And 50% more say the most important thing that Rainbow could do is to offer training. That's more than funding, that's more than access to compute, and there's not very many scenarios where you see that some people want something more than they want funding. So this is a pretty dramatic result. So the question then becomes, where does this training come from? And a challenge is that in the university system, there's not a place for it right now. So a lot of different places are developing curriculum. So Berkeley just rolled out this sort of data core, and a lot of other universities have individual initiatives. So this is something that's starting to emerge. But a challenge in not only in changing curriculum, because anyone who's tried to put a new course into a university knows that it's non-trivial, is having the instructors who can teach it. So this is a relatively new skill set. So even people who maybe started 10 years ago, these aren't the skills that they learned. So they don't feel comfortable teaching these skills. They wouldn't want to generate a curriculum. So the question is, how do we offer this training? And so Data Carpentry develops and runs workshops to fill that training gap. So when we talk about sort of gaps in training, we're actually sort of appreciative of that gap. We're working in the gaps. We recognize that they're there, and we're trying to work in that space. So we develop and run 2-day hands-on interactive workshops that teach the basic concepts, skills, and tools for working more effectively and reproducibly with data. Our workshops, so our current set of workshops are for people with little to no prior computational experience. So we don't assume any knowledge of any particular computational tools when you walk in the door. Most people have had experience with spreadsheets, and that's kind of the foundation. Our workshops are domain specific, and they follow a narrative structure. And the reason for these two elements is that when you're working with data in your own domain, when you're learning the skills, you're building it on a framework that you already have. So these are the types of questions you have, the type of data that you have. So when you're learning these skills, it's building on some existing knowledge. And the other is that then when you go back to your lab and you start to do your work, the kinds of things you just did in this workshop are really familiar, and you can apply these techniques to your own data. This narrative structure is meant to sort of represent what a standard workflow would be for a researcher, so that we go through the whole process from, so you got your data, through to analysis and visualization. So you can see the curriculum in general. There are some differences based on data type, but the general process is that we teach an introduction to the data type. That may seem sort of trivial, but that's actually not the case with particular types of data, but even tabular data. There's things to know about the data type. Data and project organization, so we've heard a lot about that, with the final and the ability to not do that with like the COS framework. Data management, data cleaning, that is often a step that's missed in most curriculum. You jump right into statistics. And data analysis and visualization. So I'm talking here about data carpentry, but data carpentry is based on software carpentry, if you've heard of that, and that was founded in 1998, but then rebooted again in 2010. And the goal of software carpentry is to teach better software development practices. So this is for people who are already programming, but want to have better programming practices, things like version control, command line. So this curriculum, there are novice versions, but it's a little bit more advanced. So once you sort of start coding, what are the better practices? So the great thing about data carpentry and software carpentry is that they're really grassroots training efforts. And by that I mean that they're developed by practitioners for practitioners. So they're really developed by the people who are doing the research, the people in this room. And so what it is that they're able to really identify the skills and best practices that are needed by the researchers in their field. It's not a prescriptive, you should be doing this, but it really comes from, what do I wish I was doing better? What do I wish the new people coming into my lab knew? The training materials, they're all collaboratively developed. So that means not just one person is teaching them. Lots of our lessons have tens to hundreds of contributors. Our workshops are all taught by volunteer helpers and instructors, and I'm going to talk about both of these components. And when I say they're collaboratively developed, they're also openly licensed, so they're all free for reuse. So we do run workshops, but people use our lessons. We don't even know about them. Someone will tweet, "Hey, using the data carpentry lesson to teach OpenRefine," and we're like, "Great, success! I didn't even know you were doing it." So it's like when people want to replicate your paper and you didn't even know it because the data was all available. It's a win. So our workshops, they follow this active learning style. So they're 2 days and they're hands-on, and it follows sort of an I, we, you model. So the instructor will present a concept, then we'll work through it together with exercises, and then the learners have a chance to work through those exercises on their own. And so we always have instructors at the front of the room. They're doing live coding, but we also have helpers so that if people run into problems while they're working through the exercises, they can get help. So it lets people get immediate feedback as they're learning, which we know is really important in the learning process. And most of all, we really try to create a friendly learning environment, especially around computational skills. There's lots of people who feel sort of intimidated or have had less than positive experiences in the past. So we really want to make this an environment where people are excited to learn and people are really friendly towards each other. We do have code of conduct officially for all of our workshops that require respect in the room. We do recognize that we can't teach everything in 2 days, but the goal is to teach these foundational skills to get people started and overcome that activation energy in terms of what they need to do and to know what's possible. Because a lot of times it's not that people aren't willing to learn something, they don't even know about the possibilities. When we start to teach things like learning how to query data, people don't even understand that you could sort of like combine statements and pull certain elements out of their data. So it really opens up a lot of possibilities for what people can do with their data and lets them be more creative and really explore the data in different ways. So the collaboratively developed curriculum, I'm not going to go to our website right now, but they're all on our website under this lessons section. So you can see when I said we had domain specific, we have materials working with ecology. That's actually tabular data. It's a survey of small mammals. A genomics workshop that's working with FASTQ files. A geospatial one working with geospatial data. Social sciences, I'll talk about that at the end. We don't have that much there yet for that one. And then we actually also have some materials for our semester-long course. It's modular. So you can check out our lessons, but if you do go to our lessons, what you'll see is that you'll see the lessons. You could see the lessons in HTML, but they're all in GitHub, so you also could click on the GitHub link, and so you have access to all the raw materials for all these lessons. You could clone these repos, use them yourself, put in pull requests, file issues, all those things. Volunteer instructors. So all of our instructors are volunteers, and we have over 400 of them globally. So we run an instructor training program with the Software Carpentry Foundation, where we're training people in how to teach these computational skills in this active learning style. So our instructor training is also a 2-day training. We have online or in person. And we teach educational pedagogy and sort of the elements that are important for teaching in this style. And what's really exciting about the instructor training program, one is that people are learning to teach, which they often do not have much experience with, even though they have been TAs or been professors. You all know that there's not always great opportunities to learn about teaching. So people take these teaching styles back to their other courses. The other thing about the instructors is that they turn into amazing advocates for open science and reproducible research. They kind of drink the Kool-Aid, we say. But because when we talked, I was really struck by Christoph's comments about sort of the collective action. And what happens with the instructors is that they really come into a community of people who really value these things and are excited about them. And so it makes them more excited about them and more of an advocate. So it's really creating this community of people who value this as a process. They're also really nice. It's super awesome. I get to work with them every day. So we have workshops worldwide. This is just our list of workshops that are coming up. This is software carpentry and data carpentry. Software carpentry has been around a lot longer, so most of these workshops, I don't know, a significant portion of these workshops, with significant not meaning statistical significance, are software carpentry. So we've taught over 300 workshops, over 9,000 learners, taught by over 200 volunteers in over 20 countries. And just last week, we ran our first instructor training in South Africa. So we're growing the community in Africa as well. You can see that's kind of missing on the map. Things about these workshops, so people are learning things, success. So, how much practical knowledge have you gained from this workshop? Again, right, we're really trying to emphasize these practical skills that, their data, you have your data, what can you do? So from a great deal to some, I guess someone learned nothing. I feel like that's a little weird, but that's okay. They feel the workshop was worthwhile, right? So this is really important when I talk about this idea of knowing what's possible and learning new things. This perspective shift is really important. So this kind of feeling that people walk away with, which isn't like, oh my gosh, I never want to see a computer again, but wow, I have my data and now I can do something with it. So in general, people feel like it's worthwhile. So there's some disagrees, right? But agree, strongly agree. That's pretty good. And in terms of it being worth their time, this is a question that's pretty important. We all have a lot of demands on our time. So most people agree that this is worth their time. So I've given an overview sort of what the workshops are, our curriculum, our volunteers. So what does this mean in the social sciences space? So most of our focus has been so far on the physical and life sciences. Part of that is that it came from an initiative with the NSF, the biocenters. So centers funded by the NSF to focus on biology. That our first curriculum came out of those institutes. So we also we have a lot of biologists, and we also have funding from the Gordon and Betty Moore Foundation, which is funding us for work in the life and physical sciences. But we have a lot of demand and interest from the social sciences community, which has been super awesome. So we do have a text mining lesson. We do have specifically for text mining. But what's in the social sciences, I was trying to understand what the important elements for training were, and we actually ran kind of a mini hackathon out at Berkeley. And what we realized is actually really that tabular data is tabular data. So there are some differences in sort of how we would talk about some of these tabular data elements, but our ecology workshop that's focused on tabular data really just requires a shift to using a data set that's more relevant for the social scientists. So the Gapminder data set is one that we're looking at that might be relevant. The Gapminder, it's population, survey of populations globally of like GDP and life expectancy. So that's on our roadmap. And actually, we just were talking with Courtney Soderberg at the Center for Open Science. She was out there a couple weeks ago, so it's great to see everybody talking about what they're doing with that. And so what came out of that is that we were talking about kind of an initiative to build materials for psychology training. So in psychology, there's a lot of these research methods course or intro to statistics courses. And what happens is that everybody has to go and develop their own like introduction to R and what is data and all these elements. And so we wanted to get people together to collaboratively develop these modules that then could be plugged in to different courses wherever people are. And also offer opportunities to train people in how to teach these materials. So this initiative isn't necessarily a data carpentry. This would be a little more focused on integrating with university curriculum. But I'm really excited about this initiative, and I was excited talking with Courtney to realize that psychology has a research methods course. Strangely, in biology, that's not the case. You can go through your whole undergraduate and graduate career without ever taking a course called research methods. You can take a statistics course, but they're variable quality, let's say. So how would you get involved? I did forget to mention, so we're a nonprofit. We're a fiscally sponsored project of NumFocus. And so what you can do if you're interested in getting involved, you can request a workshop. So if this seems like something that is useful to your community, you can go to our website and there's a request a workshop page. You can be a helper at a workshop. So that means if there is a workshop near you, you can go and be one of those people that helps troubleshoot. It's actually, it's a lot of fun. You can be a partner or an affiliate and train local instructors. So we have a partner program where you can sign up, and then we'll run instructor training for people at your university, host some workshops. You can self-organize workshops. And then, or you can contribute to lesson development. So I said all those things were on GitHub. And to become an instructor right now, we do have these 400, 500 instructors. Our waiting list actually to be trained to be an instructor is about 200 people. So we're trying to figure out how to manage that. We are small organizations. And so right now we're focusing on partner universities to build local capacity at given places. So we both have steering committees who put in an incredible amount of work as well. And these are our sources of support for our initiatives. So with that, I guess we're done.